Okay, so I've been doing a lot of studying documentation and trying to trace through what's what on this. It is two completely separate circuits, and looking at what bits I can find of examples of PC power supply circuits, typically the standby supply is a very, very simple circuit, just pretty much often just a 2-transistor oscillator with optocoupler feedback to shut it down and regulate the voltage. Now, testing, which I haven't shown because I didn't want to be distracted because of working on it live, and a slip could have been dangerous or shorted something and blown it up completely. Doing some live tests. I wasn't sure if these resistors were working, but they were all covered in this kind of glue or potting compound or whatever, which I had to strip off. I was having trouble getting readings on some of them, so I just reflowed the joints to clean them up so I could get contact with the meter. The ones at this side appear to be just bleed resistors to discharge the thing. The ones at this side are the startup resistors that power, or give the startup power to the standby supply section. Now the IC, it's a UC5, I forgot what the number is now. 8-pin power supply IC. I'll put the data on. That's the main supply control, but that's never powered up because the thing's never been fully enabled. It's only the standby supply that's running. Taking readings around here, there is voltage on here when it's powered up. It's got 5 volts across that first optocoupler. There's 3 optocouplers there for feedback and control. That one has got voltage across it. That one has as well, quite a high voltage. So that side of it is working. There's nothing coming out of the thing, or only about half a volt or something coming out of it. There's only 2 terminals on the transformer used, on the paralleled up. There's only 2 connections on the secondary of that auxiliary supply transformer. 1 big diode. There's a cap there. There's next to no voltage on that. And looking in the top, it's not easy to see. But it's between. You've got to get right in there. Looking between that one and the heatsink, and just see if I can get some better light on and zoom in a bit. That capacitor's burst, so I think that could well be the problem. I'm guessing the thing's been left plugged in continuously for years on standby, but not actually being used all that much. Because the main supply that's only energised when the computer's turned on, all the caps look perfect. They all look fine. But that one cap that's on the standby supply is absolutely gone. You can see a bit better there. So that's the next job, is take that out and see what I find. So I've got some solder wick here, the iron's on. And I've got the iron wound up to maximum because this is lead-free soldering. It can take some heat on desoldering. So I'm going to pull this out and see what state it's in. It's only a single-sided board. It's not plated through. You hear that? It dropped out. Just clean the holes a bit. So somewhere under there. Somewhere in there. I don't know where it's gone, but it's in there somewhere. Doesn't want to come out. Try a cable tie there. Oh, I see it. It's stuck in the wires. Yeah. There we go. Right. That capacitor is well and truly swollen and gone. Not leaking from the base, but I'm curious if it's actually shorted, because as I say, we've only seen 50 ohms either polarity across that. I'm zooming in a bit far, but some see. No, it's actually not that shorted. So what's it saying for capacitance? It's not a good test, it's the ESR that matters. According to that, it's not too bad. What is it? Oh, no, I'm saying that. It's supposed to be 1000 microfarads at 10 volt. It's reading about 300 microfarads. I have to find the ESR meter. Right. See what this says. It's not. It's saying it's faulty. It's not particularly brilliant, but getting a new cap in there is probably something that will help. And I don't know if there's any other capacitors on that or not. Not obvious. That's the only other connection on that track there. I think that's a capacitor or... Oh no, sorry, there's one around there. There's something next to the diode. Oh, it's a resistor. See to the right of the... That's the big rectifier down there. And just to the right of that, there's a small resistor and a capacitor, which are in series across the diode. There's a snubber capacitor and resistor there. That's the electrolytic I've just pulled out. The only other connection is that one there, which is under the heatsink. Of course, we can't see it. I think it's a choke that goes down to the next prediction there. So that could be another capacitor there. Very difficult to see in the guts of it. Yes, there is another capacitor further down. There's a lot of stuff down there. It's very, very densely packed. Right, okay, I'm going to have a dig in it, so I'll not make you suffer through that. Right, there's another one or possibly two capacitors under there that are completely inaccessible due to the subboard and the angled heatsink and the wiring. You can't even see them properly, so there's only one choice, which I thought I might as well record in case I was interested in disassembly bits. To paraphrase the song, that there heatsink is going to have to go. It's just blocking everything. So that's got two large 3-pin devices. Oh, sorry, 3 large 3-pin devices, a small 3-pin device, and a couple of tabs to hold it in place. I just started desoldering. I thought I'd continue recording and see how it goes. Probably better off just adding a bit of fresh solder to these to help them. I mean, I've got the iron on 450. Read that in there. So it's flat out. Get as much heat in as quickly as possible to try and melt the joints, rather than it kind of heat soaking everything all the way through, waiting for everything to warm up. So just trying to desolder everything and see what happens. It may or may not be better with a solder sucker on that, I don't know. I'll give it a try. some of the bulk rather than just using solder all the time. See what happens. It depends if I can get enough heat into them to do anything useful. No, it is that. It is a single-sided board, so it's not so bad as a plated through one. So that is removing such big globs that the solder sucker's now seized up. Just wait for that to free up again. Get the crud out. That's it. Just inject a pellet of solder. That's actually going better than I expected. Quite big caps around these big fat pins, which allow some air through to suck the solder through, and lots of heat, so it's flowed well. It looks like they're pretty close to done at that. I'm surprised it's gone so easy, but there you go. Like I said, I'm used to working on double-sided plated through stuff. Right, now what I normally do after solder removal like that, I get a pair of pliers and just wiggle the pins a bit. Get 2 pins together if you can. And I don't know if I can with this, they're too far apart, too much in the way. You can see, you can wiggle the pins and it breaks the pins free of the residual trace of solder on the edges of the hole. But because it's purely side to side, you're not pulling the copper off the board. As long as there's only traces left, it normally doesn't damage the board, but it does allow the things to pull out. Because if you try and wiggle them out from the top and there's still solder in the way, or still solder attachment, you might wiggle it trying to pull up on one, but the leverage is pushing down on another one and it can take the copper off the board or loosen the pad. You don't want to do if you can avoid. So that looks reasonable. I think the tags are already free. I think that one's already free completely. So I'm hoping now that should. I'll need to unscrew that little board there. So, module that the fan plugs into. That's hardwired to different things. So get that out of the way, and the heatsink hopefully is then free. Oh, how about that? It's moving at least, which is a good sign. It's a matter of trying to look at it, see which pin isn't moving, if there are any. And they're all moving. Right, brief distraction for a phone call. Okay, so this all appears as if it's going to come out. Just try pressing down one of these pins. Oh yeah, that moved. There's bits of glue or anti-vibration compound holding it to different things. A bit of silicone stuff there. There's that bit of insulation in there I noticed as well. That's separated. It all looks free at that. Oh, it's wobbling. So I've got another pull, and it's got a temperature sensor on it, but it's coming out. Remove that temperature sensor as well. It's very well built, very, very densely packed, but well built. Okay, now, so hopefully now we'll see the capacitors, wherever they are. Oh, and they're still buried. The one I'm trying to get to is there. Down there, that brown one. There's the inductor, there's a capacitor, capacitor, inductor, capacitor, and the purple wire, the standby output, is taken straight off that. After the inductor, there's the other capacitor there, and that's the output. Now there is something across there, just inboard of that capacitor. Oh, it's a resistor. I bet that's a load resistor. Down there's that pinkish looking thing. That's a little power resistor, and I bet that's the load resistor to stabilise the standby supply. So that's what I'm seeing resistance wise. That is going to be fun. Trying to get that. Oh, that's it. I think I'm about to move that other capacitor a bit, so I can just bend this capacitor at the top out of the way, and I can see straight down to that now. So that should come out now, and then I can replace them and see how it goes. So just pause for a minute, unplug the soldering iron when I have the call. Okay, the soldering iron is up to temperature again. Oh, solder tangle. Where's that? Right. Okay, so that is the capacitor that side. These seem to be going quite well with the solder sucker. I'll try that rather than messing with braiding using that. Same thing, just pull these a bit. It's not already falling out. It's still in there. I think there's just a little bit left on that lead, so I'll need a bit of solder to remove it. And now clean, well, near enough so. So the cap is stuck in place. I don't know if these will grip it. So it's got a bit more grip to them. There we go. Oh, the wires are a bit bent. That one is what? Oh, 220 microfarad, 16 volt. Wonder how that one reads. The meter again. It's not bad.